Does our universe really represent the whole, or is it ultimately just a fleeting moment in an eternal cycle of universes? Well, British physicist and Nobel Prize winner Roger Penrose knows exactly how to answer this question. He is convinced that the cosmos is subject to a perpetual cycle of destruction and rebirth. But that's not all. Penrose actually believes he has finally found solid evidence for his cyclical model. Specifically, the British scientist has identified a series of mysterious Hawking points in the microwave background, possibly marking where the supermassive black holes of a previous universe once evaporated. What is now part of the basic knowledge of cosmology was, at best, an exotic idea about 100 years ago. In fact, until the middle of the 20th century, most researchers believed that the universe was an eternal and unchanging construct. Of course, stars could be born and die, planets could collide, and civilizations could flourish and perish, but on a large spatial scale and over long periods of time. The assumption at the time was that the universe always retained its fundamental appearance. Yet, at some point, astronomers realized that distant galaxies were apparently moving away from Earth, and that the speed of this galactic escape increased with distance. Many detailed follow-up studies later, experts uncovered the true cause of these strange galaxy movements. Strictly speaking, it is not the galaxies moving through space at all, but rather space itself that is constantly expanding. In other words, experts realized that the universe is expanding, and the idea of a rigid, unchanging cosmic world was finally abandoned. However, it took until the 1960s for experts to realize that this expansion process, when viewed retrospectively, leads to an original singularity, and that the universe came into being some 13.8 billion years ago due to the Big Bang. This radical astronomical revolution had perhaps not occurred since the acceptance of the heliocentric worldview, even though we now know the Sun is not the center of the whole cosmos, but merely marks the center of our solar system. Yet, as often happens, this groundbreaking realization was linked to profound questions. If the universe was born in the Big Bang, what happened before that? What did space look like before it began to expand? And how long did it remain in this primal state? Adding to this is the fact that everything with a beginning also has an end. But what will the cosmic finale look like? Roger Penrose, with his theory of the eternal cycle of the cosmos, offers one answer. Although these complex questions are as old as the Big Bang Theory itself, clear answers remain elusive, and even theoretical considerations lack consensus among scientists. In fact, the world of astronomical research has long split into two camps on this issue. Stephen Hawking believed that asking what happened before the Big Bang is as nonsensical as asking what is north of the North Pole, since time itself began with the Big Bang. On the other hand, Roger Penrose, a theoretical physicist who worked with Hawking in the 1960s, has a different perspective. Penrose was honored with the Nobel Prize in Physics in 2020 for his work on the formation of black holes as a robust prediction of general relativity. Returning to the core question, Penrose approaches the origin and fate of the universe philosophically. He defines the universe by motion, requiring at least two objects whose distance changes over time. If only one or none exists, the space is immeasurable, with concepts like speed and time losing meaning. According to Penrose, the universe will return to such an extreme state, allowing it to explode into a new existence. In the distant future, when all matter has decayed into light, a new Big Bang could occur. Penrose believes this cyclical pattern repeats endlessly. Supporting this theory are Hawking points detected in the cosmic microwave background, which Penrose, along with other researchers, considers evidence of a previous universe. The CMB contains circular spots that correspond to the size of the full moon, potentially revealing the true cyclical nature of the cosmos. A a relic from the early days. The cosmos was created around 380,000 years after the Big Bang during the so-called recombination epoch. Indeed, the background radiation still fills the entire cosmos today, and since it was already predicted in the Standard Model, its actual detection is considered outstanding evidence for the Big Bang theory. In line with this, Penrose now believes that the detection of the so-called Hawking points is also considered outstanding evidence for the cycle theory. The bottom line is that the aforementioned spots correspond to multiples of the average CMB temperature fluctuations. The Planck and WMAP data identified these anomalies in exactly the same places, but they had been overlooked until now because it was believed that cosmological inflation would have completely erased such features. A brief explanation. Experts refer to a phase of extremely rapid expansion of the universe immediately after the Big Bang as cosmological inflation. While this cosmic growth spurt lasted only a tiny fraction of a second, it is thought to have increased the universe's size by at least a factor of 10 to the power of 26 during that time. To put it more vividly, the area that today corresponds to the entire observable universe initially had a diameter far smaller than that of a proton, and then suddenly expanded to a diameter of 10 centimeters. Cyclic models also acknowledge such phases of inflation, with the crucial difference that they locate them before the Big Bang. In other words, inflation results from the exponentially expanding distant future of an earlier eon, that is, an earlier epoch of the universe. Within the cyclic model, there is an infinite sequence of such eons, each with its own Big Bang that marks the continuation of the exponentially expanding distant future of the preceding eon. Interestingly, the adjustment from eon to eon is permissible from both mathematical and physical perspectives. The conformal compression of the cold, distant future with low density coincides with the conformal expansion of the hot, dense Big Bang of the following eon, with one exception. On paper, supermassive black holes do not adapt smoothly to the next eon. In fact, by the end of the universe, they would have almost completely swallowed up nearby galaxy clusters before finally evaporating into Hawking radiation. Due to this so-called conformal squeeze, all the radiated energy passes into the subsequent eon in the form of a single Hawking point. The photons created in this process scatter in an expanding region, but are only released when they appear in the microwave background radiation of the following eon. The corresponding region would again look like a disk with the diameter of our full moon, and it seems we can actually see such an effect in the CMB sky. In other words, these mysterious spots could mark the places where the black holes of the previous universe left their Hawking points in the background radiation. However, whether we are truly dealing with a real cosmic obituary remains disputed among experts. Roger Penrose remains calm in the face of criticism. The British physicist unwaveringly believes in the idea of a cyclic cosmos and reminds his critics that black holes were once dismissed as mere mathematical gimmicks. As we now know, they are an essential part of our understanding of the universe. Who knows which of today's still unconventional theories will one day become astronomical consensus? And now, you can become a subscriber to our astronomical content. Feel free to click on the thumbs up button and subscribe so you never miss a new video from us. See you soon.